So welcome to the June 2020 Leeds PHP Meetup. Remote again due to the coronavirus, unfortunately. So today we're going to be having a session by Zvonimir Spajic on understanding Git, followed by a short break, and then we'll be having Mike Lihan talk to us about how to build a serverless PHP API with Bref.sh. After that, we'll all join and have a chat. We'll let you into the Jitsi session so we can just have a bit of a natter. And personally, I have a lockdown beer, and I think you should all do the same. Thank you to our sponsors who make this event possible. So that's BJSS, Searchability, and Bruntwood. If you'd like to join us on Slack, here's the URL which you can do that with. And that's it from me. I shall pass you over to Zvonimir. Thank you.
Okay, thank you, Mark. Yeah, give me a second for the usual technical stuff. I should be sharing my screen and my video. Yeah. Okay. And yeah, I will take your silence as a confirmation that you can see my screen and hear me right. So I will just. So when it comes to software development, we use a lot of tools, right? And the way we use these tools is we download them from the internet, then we install them, and then we spend maybe 5-6 seconds reading the documentation, and then we just kind of use it, right? And thereon we just kind of learn by using them. We learn by doing. And this approach can often work because the creators of these tools, they go to great lengths to give us a nice, intuitive user interface that abstracts away all the inner complexities of the tool itself or the domain on which the tool operates. Now, for better or worse, Git is just not one of those tools. And it's not one of those tools because the user interface that Git gives you doesn't really do a good job of abstracting away those inner complexities of Git. Actually, Git's user interface is something that you could call like a school example of something that is called a leaky abstraction, right? So these Git internals, they just keep leaking through the user interface that Git gives you, and they keep on confusing you. Git gives you these strange messages that you can never understand, and so on. So what this means is that if you want to become good with Git, if you want to learn Git, you cannot just use it and learn it that way. You need to invest some time into learning how it works internally, how it works under the hood, so to say. Now, the good news here is that you don't need to learn everything that there is to know about Git, all the bits and pieces. Just by learning the basics of how Git works under the hood internally, you will get like a massive payoff in your daily workflow when you will start to understand Git better and be more comfortable with it. And maybe you'll even agree with me at the end of this talk that Git is actually kind of a really cool and fun tool. So today we're going to take a look at three things. First is Git's data model. Then we're going to take a look at Git's branching system. What are branches in Git? How do we merge? What does it mean to merge branches in Git? And finally, we're going to take a look at something that is called the index. So first is the data model. To paraphrase the late, great Carl Sagan, if you wish to create a universe from scratch, you must first initialize your repository. So let's do that by typing git init, and at this point, Git will give us this nice message that we can actually read and understand, which doesn't happen really often in Git, right? And what Git is telling us is that it has created this .git directory in our projects directory. So if you never took a look inside, this is how it looks when you initialize an empty repository. It has some folders, it has some files. What we are going to be interested today is this head file and these objects and refs folders. Now, for the moment, these objects and refs folders, they are empty. I mean, they do have these subfolders, info, pack, and heads and tags, but there are no objects, there are no refs, there are no files in them. So let's change that. Let's fill them up with some objects or files. So no project is a project unless it has an index PHP. So let's create one. Let's add some code to it. Hopefully we know how to exit and save in Vim. Then we add a readme.md file because somebody is going to have to make some sense out of the mess we are going to create. And again, we save and exit in Vim, we add those files, we commit them, and now we have our first commit. This is the daily workflow. We've done it 1,000 of times, and just today probably everybody did it for at least 10 times. Nothing new here. If we now take a look at the .git directory, more precisely, if we take a look at the .git/objects directory, now we'll see that there are some objects there. And there are actually 4 objects that Git has created to represent those 2 files we have committed. So let's now take a look at what are these 4 objects in a more kind of visual kind of way. So the first type of object that Git creates once you commit your files is the so-called blob objects. Blob objects are used in Git to represent the content of your file at the point of the commit. And the way that Git creates these blob objects is that it takes the full content of your file, in this case it's index.php, puts it into the blob object, and then generates something that is called the checksum header. The way that Git generates this checksum header is that it takes the full content of this object, this blob object in this case, feeds it to a hashing function, and I believe Git uses a SHA-1 function, and the output of this function is the checksum header. Now, in reality, the checksum header is a 40-character long string. The output of this function is a 40-character long string, but here I'm only displaying the first 6 characters because 40 characters wouldn't fit my beautiful image, right? But also when you are dealing with these checksum headers in Git, maybe you are passing them as arguments to your commands, to some commands. You can also usually just use the first 6 or even less characters because it's a hashing function, so the probability of collisions is not that big unless you have millions and millions and millions of objects in your repository. So as I said, blob objects are used to represent the content of your files. So there's going to be another blob object to represent the content of the readme.md file, generated in the same way. Git takes the full content of your file, puts it into the blob object, and feeds that object to the hashing function. The output is the checksum header for this blob object. So now that Git has these blob objects, Git has a way of representing the content of your files at the point of the commit. Now, in order for Git to recreate the full the state of your project at the point of the commit, Git needs to know some more information, right? Git needs to know not just what to put in these files, but Git needs to know where to put these files in your project directory and how to name these files. And this is where Git uses another type of objects, and these objects are called the tree objects. Now, here we have a really simple folder structure. We only have 2 files, so we're only going to have one tree object. And this tree object, it has a list of these 2 files, and every file in this list has a pointer associated to it that points to the blob object representing the content of this file. So index.php points to the blob object representing index.php, and readme.md points to the blob object representing readme.md. What are these pointers? Well, they're just the checksum headers of the blob objects themselves. And finally, the tree object also gets the checksum header of its own, and Git generates it in the same way. It takes the full content of this tree object, feeds it to a hashing function, and the output is the checksum header. So now Git knows how to name your files, where to put them in your project directory, and what to put in these files, what's the content of these files. So Git has everything it needs to recreate the state of your project at the point of a commit. And this is true, but you probably want to know some more information, right? You probably want to know who's the author of the commit so you can blame that person afterwards. You probably want to know what of this more metadata like that. And this is where Git uses a third type of object, and this is the one you are all familiar with because this is the good old commit object itself. So the commit object, it has some metadata about the commit. It has a pointer to the tree object that's connected to this commit object. And of course, it has a checksum header of its own, generated in the same way as with all the other objects in Git. So these are the 4 objects Git has created to represent those 2 files we have committed. Let's now take a look at what will happen if we edit one of our files. Say we go to our index.php, we add some code magic to it. Again, we save and exit and add it and commit it. So now, since we only changed the content of one file, Git only needs to create one new blob object to represent this new version, this new content of our index.php file. But it generates this blob object the same way as before. So Git will take the full content of your file, it will put it into your blob object, and then it will generate the checksum header. And as you may notice, the checksum header now is different than before for the blob object because the content of this file has changed, which means that the checksum header must change also. Because as you remember, Git generates this checksum header by feeding the content of this file to a hashing function. So if the content of the file changes, the checksum header must change also. Now we didn't add or remove any files from our project, so the folder structure of our project is still the same. So there's still going to be one tree object, and it's still going to have that same list of files, index.php and readme.md. But now the pointer for index.php is updated, so now it points to the new blob object representing this new version of our index.php file. As for the readme.md, Git will just reuse the same blob object it already has, so the pointer will just point to the same blob object as before. It kind of just copies the pointer from the previous tree object. And finally, of course, our tree object gets a checksum header. Again, it's different than before because the content of this file has changed, of this object has changed, so the checksum header must be different also. And again, there's a commit object, has some metadata about the commit, has the pointer to the tree object, and also very importantly, it has a pointer to its parent, because every commit in Git has a pointer to its parent except the very first initial commit as we see in this picture. So this is Git's data model. I think it's rather simple but very elegant, and it's actually really powerful because it allows Git to be very fast at some operations. So just to recap, blob objects are used by Git to represent the content of your files at the point of the commit. So they are like snapshots of your files. Tree objects are used by Git to represent the folder structure of your project at the point of the commit. And in reality, you're probably going to have some more elaborate object folder structure like nested folders and so on. Tree objects can also be nested, so they will mimic the folder structure of your project. And finally, commit objects, they have some metadata about the commits. And very importantly, every commit has a pointer to its parent, and this allows us to traverse the commit history of our project. So with that, we can move to branching. Now, in this image, I am displaying one branch in Git. It has 4 commits. Every commit has a checksum header. Every commit points to its parent. And I am not displaying those tree objects, those blob objects, as we just saw in the data model. We're just going to abstract it a bit, but they are still there. We're just going to now focus on the commit objects. If you type Git branch in your CLI, Git will tell you you're on this branch master. Master is just the default name that Git uses for a branch. You can change it. There's nothing special about it. But yeah, nobody ever does, but looks like we are going to change it. If you go to the .git directory, more precisely, if you go to the .git/refs/heads directory, you will see that now there's this file called master there. And actually, this is just a text file. So you can use the cat command to take a look inside. And now if you're paying attention, you will see that this string, this 40-character long string, is actually the checksum header of the last commit on this branch. So this is what branches are in Git. They are just pointers to a commit, or in other words, they are a pointer to the last commit on this branch. And we also refer to it as the tip of the branch. This commit that the branch pointer is pointing to, we usually say that this is the tip of the branch. But now you may be wondering and asking yourselves, well, if a branch in Git is just a pointer to a commit, how come when you use a command like git log, you get that long list of commits, right? You don't get just one commit. Well, the way this works is actually rather simple, and that is when Git needs this full list of commits that your branch contains, it will just locate the tip of the branch, and then it will traverse and generate this. It doesn't need, so it is useful. You can still think of branches as these long lists of commits, but Git doesn't need to keep this long list of commits stored somewhere all the time. It just needs to keep the information about the tip of the branch, about the last commit on the branch, and the full list it can generate on the fly, right, when it needs it. So branches in Git are just pointers to commits, and technical implementation is that it's just a text file containing a 40-character long string. So this is why creating new branches in Git is incredibly fast, and it's a very cheap operation, right? Because only thing that Git needs to do when you type git branch feature is create a new text file called feature in this /refs/heads directory and fill it up with this checksum header of this commit. But now there is yet another question that maybe you are asking yourself and that is, now that we have 2 branches, how does Git know which branch we are currently on, right? if we add a new commit, which one of these branch pointers gets updated? Well, this is where another type of pointer comes into play, and this is called the head pointer. And you probably already heard about it. You probably already used it, even if you didn't know what it is, because of that leaky abstraction layer that the user interface gives you. And what it is also just a text file. It doesn't contain a checksum header, but it contains, like this, as you see, a reference to a reference. These pointers in Git, they call them references. So it is a reference to a reference, so it points to a branch pointer. And if we would now check out to the feature branch, and we'll take a look inside the head pointer now, we'll see that now it points to this other reference. Now it points to the feature reference, to the feature branch. There is a special case when the head pointer can contain a checksum header, meaning that it will point directly to a commit, and this is when you will get that strange message that says head is at detached state, and then you get that weird long message and you think that everything is going to blow, but yeah, it's nothing dangerous actually. So just so you know why that happens. Now, let's say we add a new commit to this branch. What is going to happen is the feature branch pointer will be updated. So now it will point to this new commit, this new tip of the feature branch. So this new checksum header now is in our feature reference. And as for the head pointer, it still points to the same feature reference, still points to the same branch. So this is what branches are in Git. They are just pointers to a commit, and technical implementation, as I said, it's just a text file containing a 40-character long string. So now that we know what branches are, let's take a look at what does it mean to merge branches in Git, because we tend to do it quite often, right? So again, I'm displaying this master branch. It has 3 commits. We are currently checked into this master branch. Now let's say we want to develop a new shiny feature. So we create this feature branch. Now we check out to this feature branch. Now we add some commit with some new cool features, cool stuff, cool changes on our feature branch. Then we add some more cool changes, and now somebody calls us, maybe our boss, and tells us the production is on fire. So you check out the master branch, you deploy a hotfix, then you realize your hotfix introduced another bug, so you deploy a hotfix for a hotfix, and now everything is back to normal. Life is good again. And now you actually want those changes you did on the feature branch to be present on your master branch, right? You want to incorporate all that cool stuff you developed on your feature branch to the master branch, so yeah, your product can win and be the best product of them all. So in other words, what we now want to do, we want to merge our feature branch into master, right? We've all done this. But what does this mean when it comes to Git, to merge this feature branch into master? What do we want to achieve? Well, if we go to the tip of our master branch and we traverse the commit graph, we see that those two commits from the feature branch are not accessible from the tip of the master branch. And if those two commits are not accessible from the tip of the master branch, that also means that the changes we did on those two commits are not present on the master branch. So in order for those changes to be present on the master branch, those commits from the feature branch where we did those changes need to be accessible from the master branch. So this is what we want to achieve by merging a feature branch into master. We want to make those two commits from the feature branch accessible from the tip of the master branch. So this is what we're going to achieve by typing git merge feature, by merging our feature branch into master. And the way Git does it is a 3-step process. So the step is locate the tips of our branch, our master branch, and then Git will traverse the commit history, commit graph, to find the first commit that is accessible from both of these branches, from the tips of these branches. So this is the commit where our branches kind of diverge, right? And we call it the merge base commit. Now that Git has located the merge base commit, it will go to the second step, which is creating the new merge commit. Now this merge commit is not over, it is not constructed yet, but as you may notice, once it will be constructed, it will have this interesting and nice property. It will have 2 parents. And we'll get back to that later. What's the consequence of this? And now Git needs to construct this commit. So how does Git do that? This is best understood if we show it on an example. So again, now I'm displaying those 3 objects that are tied to these commits. So we need to remember a bit about the data model that we talked. So now what Git will do is Git will iterate over this list of files it has in the tree object. And again, we have a really simple project here. It only has 3 files to have a simple example. So the first file in this list is the index.php. So Git first takes a look at the merge base commit and the checksum header that it has for the index.php, for the blob object representing the index.php on the merge base commit. Then it compares it with the value it has on the tip of the master branch. And it sees that the checksum header for the blob object for the index.php file on the tip of the master branch is different than the information it has stored in the merge base commit. And what this means is that we have added some changes to our index.php file on the master branch. Because if you remember how those blob objects are created, if the content of the blob object changes, then the checksum header will also change. So if we have different checksum headers, that is an indication that the content has changed, so we have a different version of our file. Then Git takes a look at the feature branch, at the tip of the feature branch, and then it says that here the checksum header is the same for the index.php file as in the merge base commit. So what this means is that we only changed our file, we only changed the content of index.php on the master branch. So now Git is smart enough to say, well, if you only change this file on the master branch, then I guess I can take the changes from the master branch and put them into this new merge commit. Then Git goes to the second file, to the next file in this list, which is readme.md, and now it has a much easier job because now it says that the checksum headers for the blob objects representing readme.md are the same on the tips of the master and the feature branch, as well as the merge base commit. So Git can just, this means that we didn't add any changes to these files on neither of our branches. So Git can just take the information it already has in the merge base commit and just put it into the new merge commit. Finally, Git takes a look at the last file in this list, which is the app.php file. On the master branch, it has the same checksum header, so we didn't edit this file, we didn't touch it. But on the feature branch, it has a different checksum header. So again, Git says, well, if you only change this file on one branch, then I guess I can take the changes from that branch and put them into the new merge commit. And only thing that's left to do for Git now is to finish the construction of this commit object, give it the checksum header and all that stuff. And the third and final step when merging a feature branch into master is to update and move the master pointer forward, to move it to point to this new merge commit. So now that the master pointer has a new tip, from this new tip of the master branch, as we see, because it has 2 parents, now all those commits that were accessible before on the master branch are still accessible, but also those 2 new cool shiny feature commits from the feature branch are also accessible from this new tip of the master branch. And what this means is that now those changes that we did on the feature branch, those 2 commits, are also present on the master branch. So this is what merging is in Git. It's about making commits accessible from the tip of the branch you are merging into. And with this, we can move to the last topic for today, which is the index. Now, before we talk about the index, we need to talk about the so-called 3 areas of Git. Again, something that you are all already familiar with if you work with Git, because you use them daily. So the project folder, the file system on your computer, this is your working directory. And as you know, when you commit your objects, as we've shown in the data model, those commit objects, blob objects, and all that stuff is created in the .git repository. So you can think of .git repository of this .git object as kind of like Git's data storage. But as you already know, we don't commit our changes directly to repository. We don't persist them directly to Git's data storage. What we do is we make some changes, and then we add them to this thing called staging area. And then we can take a look at this staging area, and it serves us kind of this preview of our next commit. Because when we look at the staging area, this is how our next commit is going to look like if we press Git commit at that point. So we can fine tune our commits in the staging area until we are happy with how it looks. And then when we actually do the Git commit part, now those changes are going to go and be persisted in Git's data storage in that Git repository. Now there is a operation that does the reverse thing, and this is the Git Checkout Command. The Git Checkout Command will actually go to the .git repository. It will locate the commit you want to check out to, and then it will repopulate your staging area in a working directory to match the state of the project at the point of that commit. And as I just explained, I made it sound like this staging area is this kind of area, right? And it is useful to think about it as this kind of area where you can push stuff into it, you can take it back, and all that stuff. But actually, there is no such thing as a staging area. It doesn't exist. What exists is a file called index, and it's not a text file, but it is just a file. So let's take a look at how does this work on an example, and it will be a bit more clear. So here in your .git repository, again, we have our feature branch. It points to a commit. Commit points to a tree object, points to some blob objects. For simplicity's sake, I'm only displaying the last commit on this feature branch. There are many more commits and blob objects and everything. Let's say we check out to the feature branch. So the head pointer now points to the feature branch. And now the checkout branch, what will it do? It will locate that commit that the feature branch is pointing to, and now it will take the data it has there, and it will populate our index, and it will recreate our working directory to match the state of that commit. So in the working directory, it will recreate your files to match that commit. As for the index, as I said, it is a file, and you can think of it as a file that has a list of all the files in your project. In your project. So here again, we have a simple project, so there's only 2 files. And for every file in this list, the index will store some information about the file. So the information that the index stores is the time of the last update of the file, the file name, and the working directory, staging area, and repository versions of the file. Now, when I say versions, I mean checksum headers of the blob objects representing the content of these files. Because as we already kind of saw with the branching and with the data model, if the content of the file changes, then the checksum header of the blob object representing that file will also change. So we can use these checksum headers to indicate version changes between our files. So at this point, all files have the same versions in all these areas, so everything, the universe is in perfect harmony. So let's change that by adding some changes to our index.php file. So at this point, these changes are only in our working directory, and Git is not aware of these changes just yet. Git will become aware of these changes once we type git status, at which point Git status will see, oh, looks like my index file is out of sync because this index.php file in the working directory has been updated. So I need to update the information in my index first. So Git status will do that. It will update the time of the last update for the index.php file, and it will update the working directory version for the index.php file. Because now, when Git takes the content of the index.php file, feeds it to the hashing function, the output, the checksum header, that's the output of the function, will be different than the version it had stored here before. So Git will update the index information in the index about the index.php file. And then Git status will say, okay, now that I have updated the index, I'm going to take another look at the index file. And then it says that for index.php, the working directory version and the staging area versions, they are different, while the staging area and the repository versions are the same. So what this means is only one thing, and that is we have made some changes in our working directory, but we haven't yet used the git add command to stage them, to push them to the staging area. And this is exactly what Git is telling us. It is telling us that there are some changes not staged for commit. So we can stage them by using the git add command. And once we do that, 2 things are going to happen. First is Git will actually create the blob object representing this new version of our index.php file. Now, those of you who are paying really close attention may notice now that when I was talking about the data model, I said that these objects are created once you commit your files. Actually, I lied a bit at that point to keep it a bit more simple, but now you are with the truth. And the truth is the blob objects are created once you do git add. And at this point, this blob object is kind of just floating around there in the .git repository. It's not connected to anything, but it is there. It is created. And of course, git add command will update the information in the index because now this file is staged. So the staging area version in the index needs to be updated to contain this new checksum header of this new version of your index.php file. So again, if you type git status, it will take a look at the index file and it will see, again, for this index.php file, now the working directory version and the staging area versions, they are perfectly, they are a match, they are the same, but the staging area version and the repository versions, they are different, which again can only mean one thing, and that is you made some changes in your working directory, you pushed them to the staging area, but you didn't yet use the commit command to actually commit them to persist them to that Git's repository. And finally, we can do just that, right? We type git commit. At this point, git commit command will create that tree object, the commit object. It will move the pointer. It will connect everything in that Git repository, and of course, it will update the index. So now our index is again back in sync, because now both of our files, index.php and readme.md, again have the same versions in the working directory, staging area, and the repository. So this is how the index file in Git works, and it is just a file, but it kind of enables Git to have this kind of staging area functionality. It is useful to think of staging area as an actual area, but as I said, it's just a file. It's just a file called index, and this is how it works. And it's particularly useful to know how index works, because if you are dealing with, for example, the git reset command, those three modes of the reset command are different in the way that they affect the index, and a lot of many other commands in Git also affect the index. So it is useful to know about it. And yeah, if you want some additional resources, I recommend you this introduction to Git talk. It covers pretty much, it's similar to this one, because I was heavily inspired from that talk, but it goes into more detail. And another talk is Advanced Git for Developers, which is more on the practical side, so it can be a nice follow-up on this kind of more theoretical, let's say, talk on Git. And yeah, if you want to know something about the history of Git, Linus talks about Git. If you didn't know, Linus is the guy who wrote Git, which I guess explains why it's so hard, right? And yeah, thank you for your attention, and that's it. And yeah, I think we probably have some time for questions. If not, this is my Twitter handle, so you can also find me on Twitter and ask me anything.
Thanks a lot for that, Conrad. I just realised I'm using your Twitter name there instead of your real name, so thank you for that, Zvonimir. Just distracted by Hugh posting me messages. He's got some connection issues, so he's kind of talking to me over Slack. Right, so the next meetup, we normally don't have any for the next couple of months over the summer, but we decided, since we're in lockdown and we're not getting out much, basically, if we can find speakers for the next meetup, we'll have it. If we can't, then we won't. So we'll let you know on that. I don't see any questions in the chat, so we can get together at the end and talk if anyone wants to. Okay, we're going to take a few minutes break now, and then we'll pass you over to Mike.
Yeah, my connection is a bit bad, but yeah, see you in a few minutes.
Are you still screen sharing?
Okay. Am I still?
There we go. I love that Linus named Git after himself. He apparently names all his projects after himself.
Oh yeah. I mean, I think he said like Git is kind of, yeah, it was some kind of reference to kind of his personality, something like that. But yeah. So, we're having a 5-minute break, right?
Yeah, I'll just give it a few minutes in case people want to refresh themselves or get a drink, and then we'll start my next talk.
And in the meantime, we just kind of have to sit here staring awkwardly, visible to everyone. It's like that part at the start of an actual talk when like the speakers sort of stood up, but no one's ready to sit down yet. Everyone's still got their drinks, and you just sort of awkwardly hover. So thank you, people on YouTube, for giving us that opportunity.
Got a nice colourful elephant collection there in the background.
Yeah, they came to watch the show. I thought, well, I mean, normally it's a bit of a dull room, this, so I thought I'd do something to make it a bit more interesting.
Awkwardly visible to everyone. It's like that part at the start of an actual talk when like
but no one's ready to sit down yet. Everyone's still got their drinks, and you just sort of... I'm getting my own audio played back to me there. that's a weird, feeling.
The YouTube tab, it is weird that some delay.
Yeah, I've got the YouTube stream open on my phone. It's interesting. There is a bit of a delay in it. So watching kind of myself appear like a minute later. Yeah, but I'm gonna have that open so people can ask questions during the next talk. So fair enough. Watching that, you'll get ready for that.
Okay, so I think that's been a few minutes now. So now we have a talk by the amazing Mike Lehan about how to build a serverless PHP API with Bref.sh, which is certainly an intriguing topic. And I'll let you share your screen. Cool.
All right. Thanks very much, Mark. I'm delighted people can join us here in lockdown. I must say, actually, as PHP Leeds goes, this has been the least I've had to commute from Manchester to Leeds to do a talk. So to some extent, it makes it easier for me to come and talk about PHP Leeds if I can do it from Manchester. And so let me just share my screen, and then we can get going. Okay, hopefully that has come up now. And this talk, as Mark's already mentioned, is on Bref. Bref.sh is their website, which I've got open here for you. They started out with a quite very simple website, and they've got all nice design on it now and everything. So it says running PHP made simple. And the reason that Bref.sh exists is because AWS have a thing called Lambda. You have most likely heard of AWS Lambda. It has been an incredibly popular part of the AWS platform for quite a few years now. It's enabled a huge amount of innovation in this sector of serverless, coining this whole joke around serverless, that serverless is just someone else's computer. And really the cloud is just someone else's computer. So we're still just using someone else's computer. But Bref was needed because in its default format, AWS Lambda didn't support, or still doesn't support PHP. When Lambda launched, it was initially supporting JavaScript and Python, and has sort of expanded to also support Java and to support C# and Go, and then subsequently Ruby. At no point has PHP sort of made the official language list for Lambda, which is a bit of a shame. However, a few years ago, in reInvent 2018, I believe, AWS announced that they were going to launch a thing called Layers, Lambda Layers. And what Layers does is essentially allow you to run your own Docker container. And you run a Docker container which can run sort of within your Lambda function, and your function runs on that runtime. And this allows quite a lot of flexibility in terms of what you can put onto Lambda. You can put on your own custom build of things like Node and Python that were already supported, but maybe some sort of extensions weren't installed. Or you can do what Bref has done and run something that isn't supported natively in Lambda, in this case, PHP. Now, what a lot of people started doing when the layers first came out was just compiling a PHP container, because it seemed fairly easy. PHP publish official Docker containers, and then putting them up onto their Lambda functions. Unfortunately, there were a lot of pitfalls in that approach, various configurations, ways that the Lambda container runs that are different from the way that your system might run containers natively, and struggles with actually how do you handle things like a web interface. Or PHP basically relies on the idea that as you write PHP code, it's got this whole web interface in the background, things like superglobals for session and get and request and post. So you have all these different things that PHP expects to be there, and they're not, which means that if you wanted to write your own layer and run it, you end up having to make a lot of compromises. So Bref came along to essentially standardize an idea of what if we built a layer that allowed people to run their own PHP code that already exists on Lambda. And so what I'm going to do today is walk through actually using Bref, and we're going to see two kind of main use cases and a few ways you're going to configure it. If you've used serverless before, some of this will be familiar because it uses the serverless framework. The serverless framework it's just the name of a specific framework, but they've called it serverless, which is also the thing we're doing is serverless. And as we go, we'll talk around a few things like why you actually might want to do this. Why do you want to do serverless when it seems more work in some ways? I'm also on the YouTube, so I've got the YouTube live chat open on my phone just down here. I don't know why I'm pointing. You probably can't see my hands. And so what I'd love to do, given that this whole thing is going to essentially be a live coding demo, I'd love if people just kind of ask questions as we went. Now, there is a bit of a lag. I believe that the things I'm saying now will come up on the YouTube in sort of about 30 seconds. But please do feel free to just ask questions. If I see them come up on the YouTube, I will try and spot them, and I'll just try and answer you as we go, and maybe I can show you or write some code to show you what you're asking. Obviously, I might not spot everything, and so again at the end, anything that kind of I haven't covered, Mark will sort of readdress to me, and we can go over it that way. So let's get started. So we are firstly going to go over and get hold of an AWS Vault session, just because I want to do all this without having to show you loads of my credentials. Oops. Stop. Load of random things in my terminal there. And we have a project. It's a very simple project. It's got nothing in it. And so we're going to start off with requiring Bref. And now, like everything else in our PHP world, we require it using Composer. And we can require Bref. Bref is so named because it is the French word, I believe, for brief. And so the idea is that sort of serverless is brief. It's, you know, you've got this container that exists for a very short amount of time and does something for you, and then it's gone. So Bref, I guess it sounds like breath as well. But again, someone from the Bref team can correct me if I'm totally wrong about that. And you can see it installs quite a lot of things. Bref relies on a few features to run sort of natively. And then we get a bref.init command. So, oops, the serverless command is not installed. I have a strange setup with ZSH. There we go. And you run bref.init, and it's going to ask you what kind of lambda you want to create. We're going to focus on the top two today. Console applications are kind of an extra to the existing ways that Bref can work. Console applications are specifically useful if you're using something like Symfony or Laravel with Bref, where you might want access to things like Symfony bin console or artisan commands. We're not going to quite delve into that today. I will briefly touch on how you can use those frameworks though. So we're going to create a simple PHP function. So we hit 0 here. I love lists that start from 0. It feels right. And there we go. It's created some stuff for us. It's created a serverless YAML file and index.php. So let's dive in to what we've got here. So the serverless YAML file we'll start with. We're going to do a few quick renames here just to make it our own. PHP Leeds and EWest1. So the serverless YAML file, this is the serverless framework. So this is a separate system from Bref. The serverless framework allows a whole range of serverless applications to run in various languages and on various platforms, not just Lambda. But for Bref, it just does run on Lambda. So if you're using Google Cloud or Azure or any other service, Bref isn't for you at this stage. But hopefully it's still got some relevance to what you might want to do. So this is a serverless YAML file, and it's very similar to any other serverless YAML file you might have seen. It's just using the serverless framework. One of the key differences is that we've got layers here. So we've got our functions, and again, we can call this whatever we want. So I'm going to call mine hello, and I'm actually going to rename my index file to hello.php just to make it nice and easy for me. So let's just refactor this. There's a bit of lag. I think that's probably the screen share. And we have this layers list, and you'll see interesting. We've got this layer that's slightly weird. It's not a name of like a normal layer. So normal layers are in Amazon's notation for what they call ARNs, Amazon Resource Notation. This is a sort of shortcut, and what this does is it uses serverless's own registry. So serverless have a registry of containers. So this is Bref under their namespace, and it's layer PHP 7.3. It's not PHP 73. We've not gone that far ahead yet, although I'm looking forward to 8. And this is the default. We can change it. They do have a 7.4 layer now. And we also have a plugin, vendor Bref. So serverless is going to look at this plugin for any instructions it doesn't understand. And then this just stops us putting up things like our test file if we want to write tests. We don't have any, and we're not going to write any during this, but this basically means that certain things are not going to go up when we package things. And that's actually important, because when we do send code up to the cloud, there is a size limit, and the size limit is about 250 megabytes. And so all things like in your vendor directory and the actual size of the Bref layers do count towards your size limit. So that's one of the sort of first gotchas you can encounter using Bref, is that if you try and upload something really big, say you've got a Composer library that has, I don't know, some huge binary compiled files in, or some big databases, SQLite databases, for some reason in your vendor directory, you are going to find yourself maybe hitting the Lambda space limits and finding your function won't upload. So we're not going to do that today because we're uploading some super simple stuff. But if you wanted to put a production application in here, you could definitely find that's the thing. We're actually going to change this layer name, and this is just simply removing the shortcut. So the shortcut there is going to find out the latest Bref PHP 7.4 layer in my region, and I'm using Ireland because I generally deploy everything I do to Ireland. It's just habit. There isn't a region in London, it's EU West 2. So that's the actual layer we're going to use. And there is a list of these on the Bref website that you can just look at. What region am I in? Which PHP version do I want? And they'll tell you. And this also means actually you can hard code it to a specific version of the layer, which can obviously be handy if you are relying on a very specific configuration. Maybe you're relying on something in PHP INI that might change if they update the layer. And so that can be handy. And obviously what you can also see from this is you could fork this layer and edit it yourself, and then change this on. Obviously at that point you wouldn't sort of be supported by what Bref does natively. So we've got this serverless YAML file, we've got this hello.php file, which has just been created for us, and we can run it. Now we can actually run it without deploying it onto AWS to start with. So we can run serverless, invoke, and we can do local, and F is just the function name we're going to do. So it's not the file name, it's a function name. And so this function is just going to say hello, and it's going to say world. Let's make that different. Hello, PHP Leeds, or it's going to put in the name if you pass a name to it. So let's just run that now. And this is going to basically package our service. So it's going to make it into a real Lambda function. And it's also, because we've done local, it's going to actually pull down the layer. And it actually didn't show you pulling down the layer because I've already pulled down the layer since Docker's cached it. And then we go, we have hello PHP Leeds. So we've actually run our command and it's worked. So that's positive. We've tested it locally, but at the moment it's not up on AWS. So if I want to make this accessible somewhere, I need to then deploy it, and I can do that fairly easily by typing serverless deploy. What this does is the same thing as you saw here. It's going to package it, but then it's going to actually upload it to AWS, and obviously it's got my AWS key. Setting up AWS keys is totally a separate topic, but I do recommend a tool called AWS Vault, and that's what you can see here with my terminal. This is a ZSH extension that sees what Vault shell I'm in, but if you use different AWS accounts or you have different roles in them, I thoroughly recommend AWS Vault to avoid storing your AWS credentials sort of in plain text on your machine. And you can see that this actually takes a little while to start with, and what this is doing is it's using AWS's cloud formation system, which basically is an internal system inside AWS to manage lots of different resources that are connected. In this case, it's going to create an S3 bucket, which is going to actually have my code in it, and it's going to create the Lambda function, and later on it's going to create some things like API gateway endpoints as well. So here we go, we've created it, we've uploaded it to S3. And then we are uploading the zip file with our code to S3. And it's going to then update our stack. So CloudFormation is now seeing the zip file we've got in and importing that into a Lambda function so we can actually run it on the cloud. So this is just dots and dots. And I will just sort of kill time randomly while we do it. Obviously, what you'll see is that we can use the same invoking on the cloud as we do locally. We can just remove this local keyword. And there we go. It's up just in time before I had to start doing awkward small talk about the weather. So we can now remove this local and we can run it. And it takes a moment because this time it's actually submitting this up to Lambda. And there we go. Hello, PHP Leeds. Now, just to prove to you that that's actually running on Lambda, I can change my code locally and save it. And I can run it on Lambda, and you'll see that it is still the same code that we saw earlier. So it's not changed, whereas if we ran it locally, it would. You'll see we've got this event. So obviously, it wouldn't be too useful running code in Lambda if you couldn't put some sort of arbitrary data into it. So we can also invoke it with a data parameter. We can go name, and that's going to pass in that data item as that's a JSON, and there we go. Hello, Mike. So this event here has just passed into a PHP associative array, and then has echoed out whatever I put in here. And so now we want to actually have a look at what we've created. We've created this thing with Bref. What have we actually done? So what I'm going to do is I'm going to grab a, let me just get this up. I'll sign into my AWS account without doing it so you can all see my password. And there we go. So here we are on the AWS Management Console. We're going to go into CloudFormation here. And we'll probably see a bunch of test stacks that I created in preparing for this talk. Oh, we didn't. Good, I delete them. Fantastic. So here we go, PHP release dev. And we can open this stack. And it's not hugely important what's in here, but it is interesting to see the things that have been created. So, you know, we typed a few lines of code and we hit enter and look at all the work AWS did for us. It's created all these different things. We've got log groups, we've got a function, we've got a S3 bucket, we've got identity access manager, IAM roles. It's done a lot of work for us, which is great. So let's have a look at that Lambda function. And here we go, loading. You know what's really weird about this whole like live streaming thing is that genuinely I have no idea if any of you are enjoying this or like if you're even watching. So you know that's cool. So do please ask questions if you do have them. I don't like the idea of everyone sitting there going, I don't understand what you're talking about. Please let me know you don't understand what I'm talking about, and I will try and help you. But we can see that our code base is loaded into Amazon's little editor, Cloud9, and we can actually modify it on here. Now we won't modify it because obviously what happens if we modify on here is that it will go out of sync with our actual code that we've got running on our machine and our serverless deploy. So we're not going to do that because that would just be confusing. But you can do if you want to. Obviously, if you're running this in like a company, you probably want to stop your teammates editing it on AWS itself. Like that would be difficult. If everyone just started making changes to it and you're looking at it on your machine, running it and testing it and going, it works, and they've just edited it live and broken it. So you know, some sensible controls if you're using this in production would make sense. You can also see the name it's created here. PHP leads is our name that's off serverless YAML, and also hello is the name of this specific function. Now this dev is known as a stage. When you're deploying using a serverless, if you don't give it a stage name under this, at least under the provider definition, then it'll go to dev. So the idea of dev is that this is your development branch. So that you would have a separate prod branch when you actually want to deploy to production. So that's kind of the default it does, and that's really important when you're using APIs because it will actually change your API path. Meaning you can actually have an API dev path and an API live path, and you know if you break the dev path, it's not going to hose your real users, which is kind of helpful. So far, all we can do is call it from the command line if we happen to be the owner of the function, and that's not particularly useful. So we're going to get to writing a HTTP application in a moment. But firstly, there's a few extra tools we might want to use to actually understand and harness what Lambda can do a bit more. One of them is context. We can add context. Ref context. Yep. That's just a long keyword there. Yeah. On PHP Storm, help me out. There we go. Simplify that. So we can add some context to our function. And that is, let's just say something like this is, we can say context. And we get these methods we can call to get things like our remaining time. So Lambda has a time limit. You can configure a time limit at the default timeout. It can be anywhere up to, I believe the current max limit you can set it to is 15 minutes. The default is about 30 seconds, I think. So you can get the remaining time milliseconds. This is really useful if you want to run a job that's kind of going to do something. Maybe you're going to process a large number of images and you're going to watermark them. You might want to say, okay, just process all the images in my S3 bucket, but maybe you have millions. And obviously Lambda is just going to die, and then your images don't get processed. Maybe a few thousand of them get processed. So your function can actually say, you know, at each loop, get the remaining time. Am I almost up? And if I'm up, maybe I recall my function. So I put I make a command back to the AWS Lambda API and say, hey, do this again, and then I exit, and another function is going to start up and run it again. And you can kind of use that to keep iterating. And similarly, you can get your ID of your function, which is again helpful if you want to call yourself recursively. You can get your function ID, and then you can write some AWS SDK code that says, hey, call this Lambda function. So we're just going to get the invoke function on And we're gonna we'll leave that on there for our next deploy, but you'll see that come up when we do our next deploy. I also want to talk about logging. Logging is super useful. We all want to have logs, and AWS has logs built in. So you saw here that we actually have monitoring of our Lambda. We can see when it's run. I don't know why these CloudWatch metric graphs, they always take ages to load, and it's like we run it once. And here we go. There we go. Right, 2 invocations. Took a ridiculously small amount of time. There we go. And yeah, we go. No errors and one success. And we can view our logs in CloudWatch. And obviously, we don't always necessarily want to do this in the AWS command line either. We can also view our logs in our CLI. And just not to confuse things, but obviously if you did tail-f, that would tail the file. Remember, this -f is just the function name. There is a way to also tail it. I can't recall the exact command at the moment. And at the moment, our log's really boring. You get a request ID, and you get a report at the end of saying how long did it run for. Look at that, 18.75 milliseconds. Build duration, 100 milliseconds. Memory size, 1 gig. Max memory use, 59 megabytes. So for a start, I'm over provisioning. I could reduce the amount of memory I provision, and I would pay slightly less for my invocation. But at the moment, I'm paying nothing for running this. Lambda is so cheap that I don't even know what the Lambda pricing model is. And my company, Students.com, we use Lambda in production and API Gateway and Bref, and I'd never even tend to really notice them on our bill at the end of the month. So that maybe gives you some idea. I'm sure, obviously, if you were trying to run Uber off Lambda, you'll spot that cost. But it would still be units of magnitude less than running the same on something like EC2 servers. So yeah, it's definitely some interesting cost savings you can get, as well as the flexibility you get with running things serverless. So this log isn't very interesting. We want to actually log something else. If we just randomly output things like echo from our Lambda, like nothing will really happen. So what we want to do is use a logger, and helpfully the people at Bref have provided a logger for us. You'll notice, by the way, my Git branches start over. I did sort of do the whole Blue Peter thing. If I've got one made earlier, so if I completely mess up on this live coding, I can just check out the master and everything will be fine. Hopefully we don't need to do that. But in case anyone's wondering what start over means, that's what start over means. Here's our Bref logger, and we can add it to our function. Just finding the code for it with this. Use Bref logger, and we can make a logger. And this logger conform to PSR3. So for anyone who's using PSR3, any or framework that supports PSR3 compatible logger, we can do that. And now, obviously, do remember we're using a PHP style closure here. And so if you want to use something outside that context in here, you have to add a use directive. It's not JavaScript where it'll just inherit the outer scope. And also you'll notice we're doing here return function. You could do other things. You could return a string as long as that string maps to a PHP callable. So if you return a string and the string is a function name in your scope, then that'll work. Equally, you could return a class as long as that class has a _ invoke method. So anything that would normally pass a callable type hint in PHP can be returned here. So it doesn't just have to be a sort of closure function like this, but I do think a closure function is the easiest thing to read. If I looked at someone's Lambda code and I saw them returning an object, I might be confused until I looked at the fact that object had an invoke magic method on it. So here we've got this warning, and we're going to have to redeploy this to actually see it. So serverless deploy. And this will just take a moment. Let's be faster this time because we already have the CloudFormation stat. We already have the S3 bucket. We already got the function created. So all we need to do is update the code. So you see this was actually a lot faster, and it did less than this time. And you'll see that we've got an extra library. So our size is creeping up. Still in the kilobytes though, so I don't think we need to worry. And it's finished. It's deployed. So what we can do now is we can invoke again. And we'll say hello. We'll say hello to Mark this time. I've just seen Mark's question. Yes, your execution time will go down after the lambdas warmed up. So because lambdas are Docker containers, you will find that there is what's known as a cold start. Now, the cold start used to be quite brutal, especially in terms of web applications, in the region of maybe like a few seconds on your response time. AWS have improved that significantly recently, so it's kind of more like sort of your sort of low hundreds of milliseconds now, your cold start time. So it's at the point where other things, so things like database calls or user input in your application, could be a similar sort of duration. It probably takes you longer to load the massive wodge of JavaScript code that you're going to drop on your users for analytics and advert serving than it does to boot the Lambda. But it is still a thought. If your application is very infrequent traffic, you might have a cold start slowdown every now and then. But once a Lambda is run, the container stays live for sort of an amount of time. I don't think there's a precise amount of time it stays live for, but it does stay live. That also means you can get weird things. So if you rely on things like the temp directory, so if you write a file to the temp directory, you can find that on a subsequent Lambda invocation, that file is still there. Please don't try and use that to share data between Lambda functions, because you can't do it that reliably. But if you are relying on a certain file, like not being in the temp directory, make sure your file names are using UUIDs, or that you're deleting whatever is there first before you start using the temp directory. Generally, you wouldn't want to write files to directories in Lambda anyway. You just store things to S3. But yeah, that's a really good question. Where were we? We were there we go. So we've got hello Mark, this is, and then we've got our context, we've got our arm of our function, and we should have a new log line. So let's go into our search log group. This is a warning, hey, and we can also see that if we run it in the console here. To Richard's question, yeah, you could use Bref with Terraform, totally. I generally wouldn't recommend. Terraform's great for lambdas that are doing like functions, especially if you're using lambdas within AWS to like control all the parts of your infrastructure. I would not recommend Terraform for API gateway, because the number of individual little resources you need for a single route in API gateway is massive, and it's really not easy code to read. Serverless have done a really good job of making that code really easy and portable. The other good thing about serverless framework is that there's a much wider familiarity with it across like different serverless providers and platforms, whereas understanding the intricacies of like writing Terraform for API gateway that's a skill set in itself, and I can't imagine as many people doing it when serverless exists. We use Terraform for controlling most of our resources, but we use serverless specifically for deploying production lambdas. So for lambdas that are going to be user accessible or work on our actual application, we use serverless. For lambdas that are coordinating some of our infrastructure, so reacting to events and things, we'll generally deploy them actually using Terraform. So yeah, both can be done. And Bref can be done in either as well. So we've got this log now. Our log is working, and now it's time to move on to making an actual web application with this. So we're going to add a new API PHP file, and we're going to add a new function. And helpfully, here's one I made earlier. So we have our new function. Let's get the indentation right, because YAML, and we have called it API. I should restate that this name here is just a name. I can call this whatever I want. This is a file name. These two don't have to be the same. It just feels right to make them the same, but you don't have to be. And you'll notice our layers change. So we're no longer using the ARM, because we don't need to run it locally, because if you were to run it locally, you just run a PHP server locally rather than having to use Bref. And you'll notice it's using PHP 7.4-FPM. So what this is it's the same PHP container, but it's also baked in PHP FPM, which most of you are probably using to run your PHP code in production. So if you're using Apache or Nginx, you most likely have it configured these days to send PHP requests to another service, PHP FPM, which is running alongside it. Although obviously with Apache, you might still be using mod PHP, which is fine. But this uses FPM. So if you're not used to FPM, understanding basic what FPM is might be helpful, but it doesn't hugely change what you do with Bref. What it does mean is you can write PHP code that looks exactly like you would run it in your own application and then run it on Lambda. And if you sort of wonder what I mean by that, I'm not going to show you some sort of super fancy WYSI application that uses a big framework. I am going to use one part for a big framework just to kind of make it a bit clear. So I'm going to do composer, require Symfony, and HTTP Foundation. Sorry to Laravel people using Symfony components, but to be fair, Laravel uses Symfony components. And I do apologize if you hear some thunder soon. There seems to be a storm going on outside my house at the moment, so I hope that doesn't come across too badly on the recording. And we can go to API, and yeah, I'm kind of copying and pasting some code in here. But ultimately, this code shouldn't be anything weird to you. It's sort of fairly standard code that you would write in any application. If you're unfamiliar with the way Symfony does it, Symfony makes a request object because PHP by default exposes all its request data in global variables, underscore get, underscore session, underscore server, underscore post, underscore cookie. So, you generally don't want to be accessing them in your application. It's a pretty rough way to do it. So Symfony has requests created from globals, and you get a nice object-oriented interface around requests. We're then going to get JSON data. So we're assuming that someone's going to be, if this is an API, most likely someone's going to be sending a body of JSON data. But obviously you could get query string parameters. You could get like form request, form post parameters as well. We're going to decode it into an associative array. Into an object. And then we're going to, again, use Symfony's response to send a response. And obviously, again, I've chosen to use Symfony because that's what I'm familiar with. You could literally use anything to send a request, to create a request and send a response. You could just hard code it. You could use native PHP functions, sort of header, HTTP status, and echo, and it would still work. I just wanted it to be a little neater and to show you kind of you can use framework applications inside it. You're not limited to sort of bare bones PHP. So that's me. I've talked quite a lot there. Let's actually put this up as an API. And again, this is really easy. All we've done is say that there is an event. So this is a new feature. We've got events, and we're going to have a HTTP event, and we're going to have two. So any, so that's going to take post, get, put, patch, whatever you throw at it. I think it even handles misnamed events, I think. And it's going to work for /, i.e. the root domain, and anything after /. So don't get confused too much by this. If you left out this line, just running your root domain would fail. So you need two lines to run sort of any URL someone could possibly throw at you. What proxy here means is that basically anything beyond this just gets proxied. We'll see in a moment that our PHP application can see it's the URL you're calling, so it can do routing on it like you would in a normal application. And what this basically means is just anything you throw at it just goes to your same API.php file. So it's great for a PHP framework that is using a sort of front controller that's going to route your request somewhere. I'll show you in a bit how you can do sort of more manual routing inside the serverless file. So let's deploy this. You can see that once again our package size has got a little bigger because we've added some Symfony components, but not a huge amount. And here we go. And this time we get something extra. So we're told that we have endpoints. Now this is kind of our actual endpoint, and this is obviously like a representation of our endpoint. We don't want to really call that with the proxy at the end. But what it's saying is you can call this, and you can call this with anything afterwards. Let's just call our base endpoint to start with. Copying address, and here's a curl I wrote earlier. And like generally, by the time you've seen it in your serverless output, it should be ready and live, and we should be able to call it. And there we go. So you can see I've run it with the v argument on curl so that we actually get a full output. You can see that we are using AWS's certificate because we're on their domain name. You can add a custom domain name. That's not really part of what we're talking about here because it's not really to do with Bref, but you can add your own domain name to AWS through a variety of means. And we get our regular HTTP response, and we get some extra things. So obviously Symfony is sending some parts of this response, but Amazon is also adding things. So Amazon give you a request ID. This is super useful for your logging, and obviously anyone who's you're responding to gets their request ID. So they, again, if you're an API, building an API for someone, they can actually say, I got this error, and they can give you your Amazon request ID, and that lets you get straight to your logs in CloudWatch to find out what request they made, which is really, really useful. You don't have to kind of ferret around and work out what time did they make the request at, or implement your own request ID system. Although obviously you could implement your own request ID system, I'm not going to stop you. Similarly, you get an API gateway ID. So this is the ID of the sort of gateway route you've called. You get a trace ID. So Amazon has a thing called X-ray, which is basically you can step through code. X-ray won't work for code inside layers, unfortunately, at the moment. And then is it cached? And at the moment we're not caching anything, so it shouldn't be. And so there's a lot of data there, but ultimately what we got back was hello, Mike. And the reason we got hello, Mike, was because you can see that I've supplied the D parameter to curl here, so it's actually sent a body. If I omit that, we'll get the exact same thing we got earlier where we say hello PHP Leeds. Hello PHP Leeds. And that is a working API. And it's working, in this case, you had to do something slightly different, return a function. But here we just use basic PHP that we know and love. Obviously, we might want to add a few checks. So, what if your JSON data doesn't decode? So we've got a logger here. And we're going to log. We need to create our logger as well. That's why that's still showing as grayed out. And so we can deploy that too. So to answer Mark's question, I'm going to show you a simple routing. Again, it's entirely up to you and how you want to split it out. If you're building a new application and you kind of, you kind of have a very small, like nominal amount of routes, like, okay, I'm building a simple code application that's going to, edit this, update this, delete this. You could easily define those in Lambda, in the serverless YAML file, and it actually adds some nice segregation, because if you break one of those files, only one of your routes breaks. Obviously, if I use a router in API.php to handle all my routes, and I then break API.php, I have a type error or a syntax error or something in it, I host my whole application. So you kind of lose a little bit of the whole enforced segregation that you gain from using serverless. Generally, you expect serverless sort of, if you've got 10 functions, you expect, one breaks, the others don't. If you just have a single serverless function that's handling every request, you're going to run up against that as a potential problem. There is a concurrency limit in Lambda as well. So if you have your entire site routed through a single Lambda function, you can run up against the concurrency limits of how many Lambdas can run concurrently. And AWS can increase those limits for you. But I don't know if the increases are limitless, or whether eventually they say, no, this is too much, you need to start splitting that out. I imagine that generally what you would do is use this almost more like a microservice. You might have a router, but it won't be for your entire application and every single thing it does. It'll be for one area. So you might turn each of your existing controllers into one Lambda and then have a router to decide between them. That might be a kind of compromise you'd do. Similarly, Max, you've asked about the size limit in Lambda. There is not a workaround directly for the size. If your application is just huge, the workaround is to make your application smaller. And maybe, again, what we've just talked about, obviously, if you were to have different files for your different parts of your application, you could have different vendor directories. So you might actually have different composer JSON files. So rather than every library being included in every function, you might have just the functions that the libraries that function needs. Obviously, that complicates your repository structure somewhat, but there are ways around that that I don't necessarily have time to go into, but there are ways around that. Look up kind of how people handle mono repos to have different sort of composer JSON files. So we've just run this again. Let's run this with some corrupted JSON data. We all love trying to get our JSON formatting correct, don't we? PHP lead. So it's not 500, but we've not got the expected hello Mike that we thought we were going to get. Why not? Oh dear, what's going on? Let's look at our logs for this. And we were seeing here that we have okay, we got some undefined indexes. There we go. In the actual Bref code, so that's cool. You can turn off PHP level like notices, but and you see these notices are just coming natively from Bref as well. We don't seem to have a warning showing up there. I think I did test this at one point and it didn't necessarily work correctly either. Was it because I wasn't getting JSON data as false? Maybe it was that. But also a point to make is that I spent a long time when I was trialing this talk battling my head against this issue, which is I was trying to get the URI out of our request so we can show you that proxying we talked about. Get yeah. So get our request URI. Now, by default, info, despite the fact that this will happily let us write this code, info logs are just ignored using Bref logger. You have to add this to get your logs actually noticed by Bref, which, you know, fair play, but it's something you can easily miss out because you can be writing all these info logs and then you just like screaming going, why is this not working? You need a PSR log level to say that you actually want info logs to get logged, which I guess kind of makes sense because you might not want to log info or debug logs in production. So you might have a flag somewhere in your whole serverless configuration, like an environment variable that's going to pass through to here. I don't know. That's quite a lot of extra stuff to show you, and we probably don't have time for it. We're going to deploy this now, and just to demonstrate the fact that what we're doing with the path is going to work, I can literally type whatever here and it will work, and just do the exact same thing. Obviously, again, my application can get that context, and it can actually find out sort of what the user is doing. If we just let it upload, and whilst that's uploading, I will show you the sort of the next stage. I'll start typing it so we kind of get ahead of it because I'm aware that I'm sort of running over the clock a little bit. And here's how you just do your own route. So you, rather than use this proxy, so maybe you put everything through API.php. This is your catch-all route, but you want to be, you know, super secretive. You want a secret admin panel. Please never actually do this to have your secret admin panel to access the word secret, or in fact any just subdomain. That's not how we do security, but for my purposes, it works. And we can spell secret. The big problem with live coding is just spelling. And there we go, you found the secret. And so what this will do is essentially this will say that if you do get/secret, then it's going to go to this. Anything else goes here. So the in terms of your sort of ordering, your proxy is kind of checked last. So if it can find a named defined route and defined method. So if I did post secret, if I made a post request to secret, it would get this because obviously it wouldn't match the get. So only get and secret will come up with this, and anything else will go here. So if you were going to have defined routes in serverless.yaml, you might still want this here as a single, like an error handler, kind of like a method not allowed function that just tells the user what they've done wrong. So that could be quite handy for people. So let's run our dev whatever here, and we can hopefully see some logs. And we are still not getting those logs through. Well, that's something we're going to have to leave for another time. But what we can do is, if we want this request URI out, we can just tack it onto the end of here. You called. And we deploy this again. So this is deploying both this change for the request URI and our secret file, so I can demonstrate both of those to you. And again, the sort of serverless deploy, obviously this can seem like it takes a while, especially because it's deploying such small things. But imagine a deployment process that a regular application that has to deploy to a fleet of web servers would go through. This is pretty fast. So the other advantage of stuff like this is that you do get a super fast fix cycle in the event of problems. So if your monitoring goes off, or if your users start reporting problems and you spot a problem with your live code, you can, the speed at which you can do a fix is up to your own team, but the speed at which you can deploy it is very fast. It doesn't need a whole cycle of going through. Now, obviously, if your tests take ages, that's going to still slow you down. But for kind of, if you're urgent monkey patches, this is going to do really well. So if we run this again, and you see, there we go, you call / whatever. So we can use this context in a router. But equally, if I call / secret, you call why did that not get my / secret root? Maybe I was wrong about that order of parameters, and I was just lucky when I tested it. Let's test. Let's learn together. Well, see if that works. Because it does say here that / secret should work. So maybe we have just misunderstood something there. And I'm wrong about the pattern matching, which would be a shame because it seemed like a really cool thing when I explained it. I'm just confess, in reality, we haven't used the standard routing. Just this any proxy pattern matching just seems so much easier to do most things in. And none of our applications that use Bref are huge. We know we're not running our main application on it by any stretch. But what's really good about this is that previously with serverless, you had to accept that your team had to learn a new language. Now with JavaScript and Node, that's not a huge problem. A lot of web developers will know JavaScript to a level that they can start deploying stuff. But there's still a lot of gotchas when you start using backend JavaScript if you're not used to it. And the ability to use PHP. PHP is it's a scripting language through and through. So actually the whole Lambda usage fits really well with PHP. And I should mention, obviously, what we've seen is we can invoke these ones from the console, and these are APIs. But this events keyword has a whole list. If you look in the serverless documentation, there's a whole list of events that can happen. So DynamoDB, streams, S3 object changes, simple notification service notifications, simple queue service queues. Literally, pretty much every service AWS has a way to trigger a Lambda. And so you can use PHP again to do things like automating parts of your infrastructure. So we use that. We automate infrastructure with PHP, and it just keeps a lot of the things that you already know. Cloud has enough new stuff without having to also learn new programming languages just to do stuff. So the ability to do it with PHP is just super useful. And again, it does present a genuine way to migrate your application. So I'll just briefly, as we sort of, I should definitely wrap up now, touch on frameworks. So natively, Bref has guides for Symfony and Laravel. And the guides, obviously, as we see, the code should just work. But there are some requirements in terms of the way you're going to set your system up. So you're going to want to handle the way that things like log files are stored or cache files, because obviously those natively are expecting a kind of an accessible file system that's maybe persistent for longer than a few seconds. There's no point having Symfony or Doctrine or Twig write a lot of cache files every single time it runs and then them all just dying. That's not useful. And equally, a lot of the time, those applications try and cache to a local folder, and you'll find that the only thing that's writable on Lambda is /temp. So you can use it to write to /temp, but you might have some differences in speed. Obviously, what you can do with things like, especially with Doctrine and Twig, that kind of live generate like cached files, you can sort of pre-warm those in before you deploy, and then deploy the caches with your application. Same with like your router. So if you have your router output a cache, things like Composer, you might want to optimize the autoloader. So you can run optimize autoloader, remove your dev dependencies. So again, Composer, you might install PHP unit, Codeception, PHP stand, SAR, many other things. And if you just have all those in your vendor directory, they're all going up onto AWS Lambda. So run Composer without dev dependencies and run it with the optimized autoloader just to get the speed out of it. And as I say, pre-building your caching is a really good idea. So that latest deploy should have completed. Let's see if our secret route works now. Because well, that is disappointing. I don't know why it's doing that. I did test this yesterday. I am sorry. I will figure out why that works, and I will tweet aggressively at PHP Leeds so that someone spots it and retweets it when I figured out why that isn't working as expected. What was it? Was there another thing we did at the same time? No, there wasn't. So yeah, in terms of running frameworks, again, Laravel. I've not used Laravel myself, so I don't necessarily know. You can see there's things that it has to exclude when you deploy, and here we go, some custom env files. So they have got some good stuff here. Slim framework will also work, I think, relatively natively. Basically, the same thing applies to if you've got your own custom framework. Look at where your system writes to the file system, and you either can't do that, or you've got to write to /temp and be aware that it won't be there all the time. Build anything that you expect to be cached, because otherwise, if you're expecting loads of caching to improve your subsequent runs after run 1, that's not going to happen on Lambda. They're just going to get discarded when the container dies. So don't do that. I've just got one more question there from Mark. Do you find there's lots of overhead calling a non-serverless database, for example, MySQL in RDS? So the overhead in terms of calling a database. So when you want to call a resource that's more like traditional, so say you want your Lambda to talk to an EC2 instance or talk to your MySQL database rather than DynamoDB or S3, which are via HTTP APIs, you have to locate your Lambda function in your VPC, which is AWS's kind of private network. Now, traditionally, VPCs had a much bigger cold start time. So again, like up to maybe, I think people would report it like 10 plus seconds, because basically it can't just start up a Lambda container anywhere in AWS's architecture. It has to start it within networks connected to your VPC. And that was a big slowdown. They have recently, maybe about a year ago, made dramatic improvements to that, so that the cold start time for VPC Lambdas is not much different. The only problem you might have is connection pooling. So again, your traditional PHP application running on EC2 might be getting hundreds, thousands of connections, but it's probably not making that many other connections to your database. You're probably using a connection pool through PHP FVM or Apache that is making a few connections to MySQL and keeping them open to sending data down them. So you're not doing things like TLS negotiation each time. If you in Lambda, you would have to be doing negotiation for every connection, so that's going to slow things down. AWS launched at last year's reInvent, I think, a proxy, RDS proxy, and basically it's a sort of intermediary server that you don't really have any control over. It just sits there in the Lambda kind of area of AWS and maintains permanent connections back to your database, and so your Lambdas just talk to that. So all your Lambdas just talk to a local proxy, so they don't have to handle TLS negotiation, that sort of stuff, every time they make a connection. So it kind of acts like a connection pool for you. So RDS proxy, you pay, I think, just for constant uptime on that. So it kind of takes away from the serverless idea that you don't pay when your system's not running. But if you're running it on a large production system, it's probably still worthwhile to do that. Absolutely. I think that is everything we had to go through today. And I think way past the time that we expected me to take. So I do apologize to PHP Leeds organizers for that. But hopefully that is all worthwhile. So if you want to learn more about Bref, go to Bref.sh. That's where I started. There's some great talks. Neil Brooks, if you look up some of his talks, I know he did a talk that introduced me to Bref at PHP UK in 2019. So yeah, look up some of Neil's talks on Bref. And obviously, like a lot of things, it's an open source project. If you are trying to use Bref and you find it doesn't do something or you don't understand it, maybe the documentation could do with beefing up, come and contribute to it. And I think the idea of pushing PHP to be this kind of first-class citizen in the serverless world, the cries of PHP are dead are always wrong. But ultimately, we want PHP to keep evolving and keep up with other languages like Python and JavaScript that get a lot of love in this kind of new serverless containerized landscape. And we want PHP to be in the same place. So, if we can support things like Bref and actually learn and work out how we can make our applications more portable to clouds, then that does the whole community a big service. I will leave you with that. If you want to talk to me, you can find me on Twitter. I am. I'll just let me type it. I am at M1KE. How to make that really big? Huge name. At M1KE on Twitter. I'm not as active as I used to be on Twitter. Sorry about that. I also lurk on Reddit r/PHP. And for AWS stuff, you want to check out on Slack, OG AWS community. It's a great community, really good people who are going to answer your AWS questions. Please don't just come in, shout questions at people and leave. Please be part of the community and contribute. It's always wonderful to have new people join and be part of that community as well. Thank you very much to PHP Leads, to Hugh and Mark for organizing it. And I will now answer any more questions that people have. But firstly, I'll briefly hand over to Mark in case he has any sort of closing remarks.
Thanks a lot, Mike. That was awesome. Really interesting talk. As a fellow AWS fanboy, I think I'm going to have to give Bref a bit of a good playing with. So, one thing I have to mention before we go into a few more questions is we can stop the live share now and basically let people into the chat, so you can come and actually chat face-to-face, if that's the right word. So I believe there's one more question from Max. Maybe you'd like to answer that?
Yeah, sure.
Stop the recording.
Yeah, fantastic. I'll answer Max's question. What use cases do you see for using Bref? Okay, so our first use case was an interesting one. It was the need to consume an API that was poorly documented that sent webhooks. So we were, investigating this API that was going to be really good for our use case, but it was badly documented, and especially the fact that it sent us webhooks was like we didn't know what would be in those webhooks, which kind of sucks when you're expecting to do something with them. We didn't know what frequency they'd be at, what they'd be doing, and we didn't really want to just put a random route on our big monolithic PHP application on our web server that dealt with this. So we use Bref. We use Bref, which basically, it cataloged the inbound JSON, some of which was massive. It also tried to break it down for us. So, we've had 100 requests. What's the similarities? So we almost wrote a documenter for an API to say, what data types are in different fields, what fields are common, what fields are arrays and lists. And that allowed us to just deploy this, give someone else a URL and say, hey, fire data at this. And we didn't have to care what it was doing. And we didn't really have to care about the cost. It cost almost nothing. That's where we started with an API. And since then, we have used it with attached to DynamoDB. I sort of do a longer talk, which then links this into DynamoDB. Maybe you see that at some point in the future. For anyone who's also in Manchester with me, you might have seen me do that at PHP Northwest back in February. So DynamoDB is fantastic data store. Don't just jump into Dynamo thinking it's serverless MySQL. It's not. It's got a lot of its own sort of pitfalls and things to learn, but it is fantastic for being serverless. Dynamo has streams that output data. So any data that goes in can be output into stream. That's fantastic because you can bolt a Lambda function to the end of that stream and do stuff with it. So we're using that for analytics processing. So people are hitting requests on our main application. Our application logs data into DynamoDB, and then the stream goes out to Lambda, and the Lambda is doing extra processing and kind of cleaning up that data before it puts it into our data warehousing solution. So that's kind of another use case. Other use cases that we're working on, they're not in production, but working on are image fetching. So we serve millions of photos from our website. And so when people want to upload those and say, hey, can you upload these 5,000 photos? Obviously, that's not something you can just quickly, run through a request, a HTTP request on Apache. So running that in Lambda is something we're looking at. Ultimately, most things you can do on a web application or on any sort of application, you can do in Lambda. As I said, the only thing you want to be aware of, things like there are those top level time limits. So, you've got a 15-minute time limit, which, you can detect and act on. I would say that like the uses are kind of limitless in terms of what you would do, in terms of the things you'll do. I imagine the things most companies will do is you'll start to the edge of your application. You won't rebuild your whole application in Lambda from day one, but you'll have a need and you'll go, oh man, fitting that need into our existing application is a pain. That's when you want to look at Lambda, and that's why it's useful to use the language you already know, because otherwise you're not going to look at Lambda if you have to also learn a new language. So yeah, hopefully that's helpful. But tweet me if you've got any more like deep questions about that, and I can go through it with you.
As I understand it, you can use it for running things in parallel. So you may have 1,000 images and you can have 1,000 invocations of Lambda. So you would process those 1,000 images all at the same time. So that's a good use case for versus running on one specific PHP server, for example.
Yeah, absolutely.
Okay, thanks a lot for your time, Mike.
Yeah.
Always a pleasure to have you. I'm going to basically stop the recording now and open up the video chat. So if you want to join us, I think Hugh's going to paste the link into the YouTube chat.